Hey everyone, and welcome. So if you're ready to learn one of the biggest secrets to writing lightning-fast code for data analysis in Python, then you've come to the right place. Seriously, we're about to give your Python skills a major upgrade. All right, let me ask you something. Have you ever been there? You're working with a huge list of numbers, you're trying to do some calculations, and your Python code is just crawling? Yeah, it's a super common problem. Look, Python is an amazing language, we all love it, but when it comes to crunching big sets of numbers, it can feel like a real speed bump on your data science journey, right? So take a look at this. On the left, that's the standard Python way, a for loop chugging through each item one by one. It gets the job done, sure, but it's kind of clunky, right? A little verbose. Now look at the right. That's the NumPy way. One clean, elegant line of code does the exact same thing, but it's worlds faster. This is the power we're about to unlock.
So let's officially meet the hero of our story today. That beautiful, simple solution on the right. That comes from a library called NumPy. And trust me, it is the absolute secret weapon for anyone who needs to do fast computation in Python. So what is this thing? Well, NumPy literally stands for numerical Python. And its whole reason for being is to give you this super powerful object called an array. The best way to think of it, it's like a regular Python list, but on steroids, specifically designed for high-performance math and scientific computing.
And you know what? Getting started is so simple. First, you just import the library. We usually give it the shorthand NP. You'll see that everywhere. Then you just use np.array and pop your list of numbers right in there. Boom, that's it. You've just created a NumPy array and you're ready to tap into all its power.
But, creating an array is just step one. The real magic, where NumPy truly shines, is in its built-in superpowers. These things let you perform complex math on entire datasets, like instantly. This is where things get really, really cool. Okay, remember that clunky for loop from before? Gone. With NumPy, if you want to add 2 to every single number in your array, you just write r plus 2. That's it. It's called an element-wise operation, which just means the math is applied to each element automatically, no loop needed. It's a total game changer. And it's not just for simple stuff like addition. What if you need the square root of every number? Again, one line, np.square of r. NumPy has a huge collection of these pre-built operations, which are called universal functions, or ufuncs for short. Just think of them as these highly optimized functions ready to work on your entire array at a moment's notice. So really, you can think of NumPy as this incredible toolkit that you get right out of the box. You've got your basic element-wise math, plus, minus, multiply, divide. You've got these powerful universal functions for more complex stuff like square roots, sines, cosines. And then you even have aggregate functions that can instantly give you the sum or the biggest number or the average of your entire dataset with a single command. It's all just there for you. Okay, so at this point, this probably all seems a bit like magic, right? How is it so fast? How does it do all this without us writing a loop? Well, we're about to pull back the curtain and look at the core concept that makes this whole thing possible. The secret is a concept called vectorization. Now I know it sounds like a fancy word, but it's really a simple idea. Instead of dealing with numbers one by one in a loop, you perform the operation on the entire array, the entire vector, all at once. Think of it this way. A traditional for loop is like being a manager who has to walk over to each worker's desk one by one and give them the same instruction. Okay, worker 1, add 2 to your number. Then you walk over to the next desk. Hey, worker 2, you add 2. It's so slow and inefficient because of all that back and forth, right? Now, vectorization, that's like the same manager grabbing an intercom and making one single announcement to the entire floor. Attention, everyone, add 2 to your number now. One command and the action happens across the board, all at the same time. That is where NumPy's incredible speed comes from. And here's exactly what that looks like in code. Let's say you have 2 arrays. R1 is 1, 2, 3, and R2 is 4, 5, 6. Normally in Python, you'd need a loop to add these together. But with vectorization, you just write R1 plus R2. And NumPy is smart enough to add the first elements together, the second elements together, and the third elements together all at once, under the hood. So cool. So, why does all this matter? I mean, why have we spent all this time on arrays and vectorization? Well, because what you've just learned isn't just some cool programming trick. It is the absolute foundation of modern data science. Seriously,
When you hear about these amazing fields like data science, machine learning, artificial intelligence, you have to know that NumPy is the bedrock they are all built on. The powerful tools that data scientists and AI researchers use, they all rely on NumPy's speed and efficiency to handle just massive amounts of data.
I really can't say it any better than this. NumPy isn't just another library you can learn. It is the backbone of modern data science. Learning it isn't just helpful, it's absolutely essential.
So there you have it. You now know the secret to unlocking incredible speed in your code. You've seen the magic of vectorization. So the only question left is, now that you have this superpower, what problem are you going to solve first?